Hey, what's going on, guys? Easy here. So this is my Arduino Nano that has just arrived, and I've already plugged this into the breadboard, and this was a little bit challenging, so I just want to say a few words on how to manage to do that. For those noobs like me, complete noobs in electronics, but I'm a programmer, and for me, to be honest, it's incredibly challenging to work with the real hardware, plug this tiny little jumpers in and things like that. So just a few words of what did I do here. So uh, the problem is that Arduino didn't fit into the bitboard initially, and what I needed to do in order to make it actually working, so I used these jumpers, and I did put the jumper into the hole just to make hole wide enough so it can fit the Arduino in, right? So you see, like it's really tight, and I did this for every single pin required for Arduino to be plugged in, all right? So you see, like I got two here, and I did this for all the pins. So here on the breadboard, so for every single pin, I did take a jumper, and I just was plugging them like one by one here, so to make the holes wide enough, and then I managed to plug this in. Well, the very last thing, just connect the USB cable, which was the part of the kit. So here is the USB cable, right? Now let's try to connect this to the laptop, download Arduino software, and upload the sketch allowing the LED to blink. And if I'm not mistaken, this exact LED is going to be blinking after. So this is the power, the serial read, serial write, and the resistors. I guess this should be the resistor. The resistors. It's so small I can't even see what is there, to be honest. And yeah, just to give you an idea in regards to the size. So if you have a look at the USB flash drive, you see like it's actually the size of the USB flash drive. So it's really small, and this makes this tiny little Arduino really awesome. Okay, so let's have a look if it works. Alright, so you need to navigate to Arduino website and then go to the software tab and download the Arduino IDE from there, depending on what operating system you're working on. So I would be using this Linux 64 bits because I'm using Linux Mint. Alright, so let's have a look. And yeah, just download. Alright. And well, from a previous experience, I remember that you need to have Java installed in order to run it. I'm not sure how this works on Windows, but on Linux, you really need to make sure that the Java is installed. So let me just quickly check. Yeah, I have the Java runtime environment being installed, so it should essentially kind of work. Let's just try to go straight forward. So it runs this file, this one. So if I just say sudo and Arduino like this, yeah, probably. Well, at least now I'm running this as the super user, so it should allow me to talk to serial port to my USB. Okay. What about? Yeah, so I need to change the board to Nano. What else? Yes, should be fairly enough. Okay, let's try to. So where is my sketch? Verify, save. Okay, and upload. Whoa, done uploading. Okay guys, so this is the moment of truth. I will now try to power up my Arduino Nano program to blink the LED 1 second using the smartphone charger here. And I really hope there won't be any smoke after. Well, at least I just called my dad to make sure that it won't blow up. It won't blow up, right? So yeah, anyway, we either see how magnificently it's working or the most epic Arduino Nano blow up video. So yeah, let's try. Oh my god, I'm so afraid to do this. And oh my god, it didn't blow up. Oh my god, can you believe this? This is so nice. This is what I'm gonna be building my big computer from. So cool. So just let's try to print something to serial port. So if I just say serial.begin 9600 baud. So this is the speed. And here, for instance, I want to say serial.println, and let's say hello Arduino Nano, right? So print line should print the new line already, and so now let's verify this. Let's open the serial monitor, and now if I upload and run this, it should be printing like from the device here to this serial monitor. It should be printing the hello Arduino string. So let's see if that is the case. Done uploading. Oh, is this sliding fast? Okay, so serial monitor. Yeah, and it prints the string every second, which is cool. Which means that actually we did manage to make it work, which is really awesome. Okay guys, so now at the very end, a little bonus. So what am I going to be doing with this tiny little Arduino Nano? Just a very quick demonstration of what am I supposed to be building. So I already have the breadboard. I have the Arduino Nano instead of Arduino Uno, right? And if I just start the simulation, once the LCD and the keypad arrives, I would be able to build this and show you how it works, like entirely. So here I've created an imaginary processor with a set of commands. So here are the commands, and now I'm writing an assembler in Python to actually to make it possible to actually write the programs for this computer in assembler, not in machine codes. Right, and then we have the interpreter that actually executes these commands. Quite pretty simple. And also in the main loop we have a bunch of commands. So I'll now demonstrate how this works. So it's really tempting to try this on the real hardware, to be honest. Yeah, so let's start for instance by this clear command. So in order to make clear, I need to type F A, and it says it's clearing the screen, and here we go. Then for instance we can start new, so like software reset, so FFFB, and creating, so just restart, so it clears the memory internally, it's clears the memory, clears the CPU registers, the emulated CPU registers, I mean. Well, then we can have a look FFFC, for instance. We can have a look at inspect whatever memory address we're interested in. So let's consider some memory address, and here we have the memory dump, only 4 bytes, but yeah, that's good enough for such a tiny display. So we can also, so load is not implemented yet, but save is actually implemented. So if I say FFFE, and for instance I have some bytes been written already, that they would get stored, they would be sent to the serial port. So that's how this is intended to be communicating with the outer world. So FFFE and save, right in serial ports, and starts writing bytes. But as far as I don't have any bytes there like being defined, so I didn't write any program yet. It just prints the zeros, and if you have a look at the serial monitor here, it's like it just prints to the serial port. So yeah, I would be able to so let me just unplug my Arduino. So this simulation doesn't relate to the real device at all. It's just a Tinkercad simulation. So the idea is that once this little guy actually is transferring the data via the USB to the computer, so if I did write some program here, I can then transfer this. I would be able to transfer this to my laptop, which is really cool. All right. Yeah, it takes time, and it's really kind of retro style, old school, when they were using the tapes in order to load the program and save it. So it could have been done faster, but I really like when it goes this like slowly, and it writes exactly one kilobyte, 1K of information. So literally snapshots the entire memory that is used here in this computer, and it just drops this to the serial monitor. And then it would be possible to take this, like just copy this,
copy paste and turn this either to binary file or just store it like this, or well, I didn't decide yet how exactly this is gonna be done. But anyway, once it has done, it says like the 1K bytes has been sent, right? And that's pretty much all about it. So now the most interesting thing is we can actually write programs here. So let's write the program that prints A to screen. So in order to do this, if I specify not the command listed here, but just an arbitrary memory address. I start from this one because that's where the program counter is pointing to by default. So just, is this really like that? I don't remember how did I do this. I just want to find the reset CPU. Clear RAM. Yeah, program counter points to 0. Yeah, so yeah, this is the case. And now let's input some machine codes to actually print the ASCII character A onto the screen. So LDI is 0, 1. Then the value for ASCII character A is 61. In hexadecimal, this is always hexadecimal. And then to print this to screen, I need to use this out command. Where is the out command? Here it is, 0F. So 0F, and just input something to enter the information, because it doesn't have enter key. Only 16 keys, like from 0 to 9, from A to F. Right, and here is the program. And if I now try to run this, so just let me find the run command. Run, so I need F. So now if I say F, and now it runs and it prints A. So just execute it. Well, I still need to debug this. It steps into the illegal opcode somehow. Well, but it doesn't matter really at the moment. So we've just executed the program, and yeah, I just can't go back from here. Just still debugging, but just wanted to give you an idea, like what in particular am I going to be building using this Arduino Nano. So I hope it makes sense, and once I manage to make this project kind of alive on the real hardware, I will then make a presentation video on how this actually works on the real hardware. I still need to work on this kind of like operating system on an assembler to debug, writing data in, reading data out from the device, things like that. And once I'm done, I'm gonna be making a full-blown tutorial on how to build this tiny little computer absolutely from scratch using the real hardware. And yeah, hopefully in a couple of days, I really hope that the LCD display on the keypad is gonna arrive. No, the keypad should be different. There won't be any letters or digits on it, just the plain kind of like buttons. That's pretty much it. Okay guys, so this is it from my side. So I hope you've enjoyed this video. See you in the next one, and until then, and take care.